Very warm welcome to everyone joining us today from our studio from across the globe. When we gaze up at the night sky and when you're looking at the countless stars, each like a distant sun, but imagine the heart of our own galaxy, the Milky Way, a place of unimaginable density where the stars are packed tightly together, spiraling around a cosmic behemoth, which is the supermassive black hole known as Sagittarius A star. For years, our best theories have predicted that these powerful giants should be a cosmic slingshot, constantly spitting out stars at incredible speeds. Yet, recent observation tells us totally a different story. The stars just aren't being ejected in the numbers we expected. So today we are diving into one of the most perplexing puzzle in the modern astronomy, that is uh, Galactical Core Mystery. And the question is, why aren't stars getting spitted out? What does this baffling discovery means for our understanding of the black holes and star formation and the very dynamic of the Milky Way? Join us as we unravel this cosmic riddle. So let's continue. Our galaxy, the Milky Way, is a vast spiral island of hundreds of billions of stars, gas, and dust. And its very core, approximately, which is 26,000 light years away from us, lies a region of extreme conditions, a dynamic, chaotic, and incredibly powerful environment known as the galactical center. This is where the matter is densest, stars are closest, and gravity is the king. And at the absolute heart of this region sits a colossal entity which we call Sagittarius A star. Why Sagittarius? Because it exists in the constellation of Sagittarius, and A star is the largest so-called star in our galaxy, or Sag A for short. This isn't just any black hole, it is a supermassive black hole, an object with mass equivalent to about 4 million times that of our sun. Huge. And all of this mass crammed into a space smaller than Mercury's orbit. We have known about this presence for decades, primarily by observing the frenzied orbits of stars very close to it. Stars that whip around Sagittarius A at the speed reaching thousands of kilometers per second, like cosmic roller coaster. More recently, the Event Horizon telescopes provided us with that stunning direct image of a black holes, giving us a visual confirmation of these incredible gravitational wells. The sheer gravitational force exerted by Sagittarius A dominate its immediate surroundings, influencing everything from the movement of gas clouds to the formation and destruction of stars. It is an engine, a doer, and theoretical, cosmic catapult. So either it absorbs the star or it basically throws them out. Given the immense gravitational power of this Sagittarius A and the incredible dense stellar population around it, our established theory of black hole physics and stellar dynamics lead us to a clear expectation, and that is the galactic center should be, prolific producer of hypervelocity stars. These are the stars that are flung out of the galaxy at such incredible speeds that they overcome the galaxy's gravitational pull and are destined to escape into intergalactical space. There are primarily two main mechanisms that we expect to drive this spitting out process. First, the tidal disruption event, or TDEs. Imagine a star innocently orbiting a black hole, but it gets just little too close to the point where the black hole's gravitational pull becomes overwhelmingly strong on the side of the star nearer to the black hole, and then on the far side this differential gravity stretches and spaghettify the star, tearing it apart. While some of the star's material fall into the black hole, a significant portion can be violently ejected outwards, sometimes at speeds reaching thousands of kilometers per second. This ejected material, still potentially coherent enough to be considered a star, becomes a hypervelocity star. The second mechanism involves three body interaction, specifically with binary star systems. Many stars in our galaxy are not solitary like our Sun, they exist in pairs, orbiting each other. If such a binary system uh, or a star system strays too close to the supermassive black hole, the black hole's gravity can brutally disrupt the pair. It might capture one of the stars into a tighter orbit while simultaneously using its gravity to slingshot the other star away at an extreme speed, sending it hurtling out of the galaxy. These aren't just theoretical musing. We have observed some hypervelocity stars elsewhere in the galaxy, far from the center, and their trajectories suggest they originated from the galactical center. However, the number don't add up, especially for the kind of stars we would expect to see ejected. Here is where the mystery deepens, and the challenges are assumptions. Despite the theoretical prediction and the incredible activity around Sagittarius A, observations from powerful telescopes, including the Hubble Space Telescope and more recently the James Webb Space Telescope, those devices have revealed a puzzling absence. We are simply not seeing the expected abundance of young, massive, hypervelocity stars being continuously spat out from the galactical center. When astronomers look at the innermost region of our galaxy, particularly the center, which is center parsec, which is about 3.26 light years, around the Sagittarius A, they find surprising population of young massive stars known as S stars orbiting the black hole. These stars are incredibly bright blue and short-lived, implying that they must have formed relatively recently in this extreme environment, and their presence itself is a puzzle, as the intense gravitational tide and radiation from the black hole should make star formation very, very difficult. But the absence of the ejected young massive star is equally, if not more, perplexing. If the tidal disruption and the binary stars interactions are as common as and powerful as predicted, we should be seeing a steady stream of these high velocity, bright young stars fleeing the scene. Yet, the numbers just aren't there. It is like having a giant cosmic cannon that should be firing constantly, but all we hear are a few muffled pops, not the booming barrage we anticipate. This discrepancy forces scientists to ask, are our models incomplete? Is there something fundamental we are missing about the physics at the heart of our galaxy? So, if the stars aren't being spat out in the expected number, what could be the situation? What could be happening? Scientists are now grappling with several intriguing hypotheses, each attempting to explain this galactical core mystery. First, perhaps the star formation process itself is different or inefficient in the galactical center. Maybe stars form, but they are quickly destroyed by the extreme radiation and the tidal forces before they can be ejected. Or their formation doesn't favor the kind of binary system that would lead to ejections. The presence of young S stars that haven't been ejected suggests that the star formations can occur, but their fate or the conditions leading to their existence might be unique. Second, the dynamics of the gas and the dust in the immediate vicinity of Sagittarius A might play a more complex role than previously thought. The black hole is surrounded by a vast cloud of gas and dust that form accretion disks as they spiral inwards. This chaotic environment could be absorbing or otherwise interfering with mechanisms that would normally eject stars. Perhaps material is falling into the black hole is much smoother less disruptive manner, or any ejected star are quickly hidden or slowed down by the dense gas. A third intriguing possibility involves magnetic fields. The galactical center is known to have incredibly strong and complex magnetic fields. These fields could be challenging gas and dust or even influencing stellar orbits in a way that our current purely gravitation model don't fully account for. They might be acting as a kind of cosmic damper, preventing the violent slingshotting of the stars. Finally, while less likely to be fully explained, the absence of massive stars, some theory consider the possibility of intermediate mass black holes lurking in the vicinity of Sagittarius A star. These smaller black holes could also subtly influence stellar orbits, but their presence alone wouldn't explain the overall lack of massive star ejection expected from the supermassive black hole itself. The current state of research suggests that all these factors might play a role, or there could be entirely new physical mechanism at play that we haven't yet discovered. So, why does this missing star mystery at the galactical center matter so much? Because solving it has profound implications for our understanding of some of the most fundamental processes in the universe. Firstly, it challenges our model of black hole galaxy co-evolution. Supermassive black holes are thought to profoundly influence the formation and evolution of their host galaxies. If our closest supermassive black hole hasn't been behaving as expected, it forces us to re-evaluate our theories about how these cosmic giants interact with their surroundings and shape galactic development across the cosmos. Secondly, it directly impacts our understanding of the star formation in extreme environment. The conditions near Sagittarius A are unlikely almost anywhere else in the galaxy. If the stars are forming and behaving differently there than our theories predict, it opens up new avenues for research into stellar astrophysics under extreme gravity and radiation. Finally, and perhaps most importantly, the Galactic Center is our closest laboratory for studying a supermassive black hole up close. We can resolve individual stars and gas clouds in this region with level of detail impossible in other galaxies. If we can't fully understand the dynamics of our own supermassive black hole, it means there are significant gaps in our knowledge that needs to be filled before we can truly comprehend the behavior of black holes across the universe. The Galactic Core Mystery stands as a testament to the fact that even in the age of advanced telescopes and sophisticated theories, the universe continues to hold surprises. This isn't a failure of our science, it is a vibrant illustration of how science progresses by observing the unexpected, questioning our assumptions, and pushing the boundaries of knowledge. The missing hypervelocity stars from Sagittarius A are not just an anomaly, they are cosmic invitation to explore deeper, to refine our models, and perhaps to uncover entirely new laws of physics. So, with upcoming missions and the research continued, by the astronomers, we are poised to gather even more data that might finally unlock the galactical riddle. The heart of our galaxy beats with the secret, and the search for answer continues. So, friends, thank you for joining me today for this fascinating exploration of our universe's great unknown. We hope you have gained a new appreciation for the mysteries that still abound in the cosmos. Until next time, stay curious, keep looking up, and wonder at the universe's endless puzzle. Bye for now.